Hi, this is Mr. V, and in this video we are going to use shadows to determine the height of large objects by applying our knowledge of similar triangles. So here's the situation. We have the sun, and it's casting down these rays of sunlight. And those rays are pretty close to perpendicular. Close enough for what we need to do here. So here's the ground, and here's how it works. What we can do is we can take something that we know the height of, for example, a stick that is 1.5 meters high, and we can measure the shadow of that stick, and that will form a triangle. And we can use that and compare it with some tall object, like a tree, whose height we don't know, but we can measure the length of its shadow. And again, there's going to be a triangle in there. And for the keen observers, you'll notice that's actually the same triangle, just one is smaller, one is bigger. And that's exactly what we said about similar triangles. So we can use similar triangles to solve for this unknown height of the tree. If we know that the shadow of the tree is 31 meters long, the shadow of our stick is 3.8 meters, and the height of our stick is 1.5. So, to solve this, I'm going to use similar triangles. I'm going to put my unknown first, at the top first. And I'm going to divide it by the other known, which is my horizontal, 31, equals the same ratio of sides in the other triangle, our smaller one. So 1.5 over 3.8. And I can rearrange this by multiplying by 31 on both sides. And putting that on my calculator, tells me the tree is 12.2 meters tall. And I did not have to climb up the tree to measure its height at all, which is just really handy. And that is how we can use shadow reckoning to determine the height of large objects.